Hi guys, welcome back to another video. In this video we will solve furthest building you can reach LeetCode problem. This is a medium problem, and in this problem we are given three parameters: heights, bricks and ladders. We start at index 0 and we have to return the max index that we can reach from 0th index to the ith index. The conditions are as follows. If the height of the next building is less than equal to the current building, we don't have to use any bricks or ladders. And if the height of the next building is greater than the current building, either we can use bricks or ladders. We can climb the next building with a ladder, even if the length is infinite of the next building. Else we have to use bricks, and bricks are limited in number. So the condition is, if the current building's height is greater than or equal to the next building's height, you do not need to use any ladder or bricks. If the current building's height is less than the next building's height, you can either use one ladder at a time or the difference of the next building minus current building bricks. Initially, we are at the 0th index. To solve this problem, we cannot simply just calculate the difference of the current building and next building and use bricks at a time and then start using ladders when all of the bricks are consumed. We will use a priority queue. Say where pq is equal to new priority queue, and we will save integers, and we want to store the integers in max heap fashion. That is, we want to get the max value on whole. That is, we need max value at the top of the queue. So we will use collections dot reverse order. We will start iterating from the 0th index until the end of height. Then what we will do is, we will check if the height of the current building is greater than equal to the height of the next building. It will be heights. If the height of the current building is greater than equal to the next building, simply continue. We don't have to do anything else. We will first decrease the count of bricks by the difference of height. That is, int height diff is equal to height of next building minus height of the current building. Then the updated value of bricks will be height diff. We will check the value of bricks is greater than 0. We or what we can do is, if we have consumed all of the bricks that we have, we will first check if the number of bricks is less than 0, then that means the current height difference is greater than the number of bricks we had. What we will do is, we will poll the max bricks that we can. That is, bricks. We will simply increment the count of bricks by the max value that we can get from the queue. That is our priority queue. Now we will check if ladders is less than 0, and that means in our current case we already have bricks less than 0 and ladders less than 0. Then that means this is the end. We will simply return the index. If the ladders is less than 0, we will simply return the current index because that is the max index that we can reach. Now what we will do is we will increase the count of ladders by 1, and if we have iterated over all of the indices we will simply return the last index of the heights array, that is return heights dot length minus 1. Let's see how our code performs. We have an error due to a typo. It should be heights. Bricks, what it's saying is null. Okay, we forgot to offer the height difference. What we will do is we will simply offer the height difference. Okay, as you can see, there is something wrong with the implementation. Okay, the error is this statement. It should be less than equal to because we have to exit in case we have 0 ladders. This was not considering 0. This should work. Our solution has been accepted. Let's look at the time complexity. Time complexity is n log n, and the space complexity will be big O of k, or let's say big O of n.